Okay, that brings us to Objective 5, distinguish between inductive and deductive reasoning. Alright, let's look at this, going back to our colds that we talked about in the beginning. Fact 1, fruits and vegetables contain vitamin C. Fact 2, people that have diets that are rich in fruit and vegetables are generally healthier. And fact 3, vitamin C is an anti-inflammatory agent that reduces throat and nose irritation. So knowing those three things and using inductive reasoning where we're combining all of these observations into a general principle, we come up with a hypothesis that consuming vitamin C decreases the risk of catching a cold. And we have used deductive reasoning. But let me remind you of something or caution you about something. Just because it makes sense doesn't always mean that hypothesis is going to prove to be true. So again, our hypothesis is consuming vitamin C decreases the risk of catching a cold. It's sensible. We need to test it, and we may prove it to be false. So it's a good hypothesis. Look over here on the side. First of all, there's two ways of coming up with a hypothesis. One is to use deductive reasoning. The other one, of course, is inductive reasoning. This is using deductive reasoning. Consuming vitamin C reduces the risk of catching a cold. Remember, that's our hypothesis. If vitamin C decreases the risk of catching a cold, then people who take vitamin C supplements will experience fewer colds than people who do not. So now we can conduct an experiment to compare the number of colds in people who do and do not take vitamin C supplements. We have used deductive reasoning, not inductive reasoning. Deductive reasoning is a prediction that we think will explain the possible outcome. It's just a prediction. A lot of times you'll see it written as an if-then statement. If vitamin C reduces the risk of catching a cold, then people that take vitamin C will have fewer colds. That is deductive reasoning. Now, we do this test, and if you look over on the left side of the graphic there, if the people that take the vitamin C suffer fewer colds, then we conclude it's true. So we don't reject that hypothesis. We're going to do some additional tests and maybe consider an alternative hypothesis. But if people that take vitamin C suffer the same number or more colds than people that don't, then we say it's false, and we totally reject the hypothesis and have to consider an alternative. So you can see that by using deductive reasoning, we have not really supported that hypothesis. Even if we say it's true, we're going to have to do some more testing and consider some alternatives. So we haven't really rejected it or proven it if we use deductive reasoning like we will if we use inductive reasoning. Why is it impossible to say that the hypothesis that vitamin C prevents colds is true? Is it because lab experiments are not practical? Could you bring your test subjects into your lab and perform this experiment? Might be a little difficult to do that, to get them to stay long enough to really see the results. Alternative hypothesis might be possible. Maybe they're doing something besides just taking vitamin C. Maybe you've got more than one variable in your experiment. Experiments with humans are unethical. Well, it depends on what you're doing, but in the case of vitamin C, I don't think that's unethical. If we were trying to clone them, it would be unethical. Or give them something that we know harms them. Vitamin C cannot be obtained naturally. Well, of course it can. All you gotta do is eat an orange. The reason we can't say it's completely true is because of that alternative hypothesis that may be out there that we've not even proposed yet. They may seem true because we didn't totally reject it. But if we propose a new hypothesis, we may come back and reject this one. So that's why it's so important that scientists communicate with each other, because scientific knowledge relies on rejecting incorrect ideas and working together.